So in this segment, we're going to be looking at computing the percent dissociation of an acid. We're going to be getting comfortable with Ka calculations, including knowing when you can take shortcuts and solving for various concentrations, and calculate pH and other reaction equilibria for weak acids. Okay, so percent dissociation. We know that weak acids don't entirely dissociate. They just dissociate to some extent. And actually, most of them don't dissociate very much. So we defined the percent dissociation as the percentage, as the amount of acid that is dissociated in solution divided by the amount of acid we initially added. We times 100% to make it a percent. So if we have a weak acid, for example, we put 0.5 mole of acid in a solution and 0.45 dissociates, then the percent that's dissociated is 90%. So turns out that actually would not be a very weak acid. Let's practice this. So what is the percent dissociation of a benzoic acid solution with pH 2.59? The acid dissociation constant for this monoprotic acid is 6.5 times 10 to the minus 5. Well, let's see what we can do. Okay, what information do we have? Well, we've got the Ka. We don't have much, but we definitely have the Ka, and it turns out that is pretty much enough because the Ka, the expression for that is Ka times the concentration of the dissociated acid, right? A minus is the dissociated acid divided by Ha. And so this, let's rearrange this a little. Let's rearrange it so we divide both sides by H plus. So Ka divided by H plus, that would be A minus divided by Ha. So the percent dissociation is the initial amount. Now, looking at this, if it's a, the concentration of Ha here is the concentration at equilibrium. Now, we wanted the amount with the initial acid, but if that's a relatively if it's a relatively weak acid, then the initial amount and the amount at equilibrium are about the same. So let's assume it's a weak acid. Let's see what happens when we do that. So we plug this in. We've got Ka. It's 6.5 times 10 to the minus fifth. And the concentration of H plus, we have that. It's 10 to the minus 2.59 since we have the pH. So that ends up being 6.5 times 10 to the minus 5 divided by 2.57 times 10 to the minus 3. And that gives us 2.52 10 to the minus 2. So that gives us 2.5% dissociation. So this is essentially, it's a very weak acid. Not that much is dissociated. So we can approximate to a pretty good amount that the percent dissociation is just 2.5%. And this is pretty typical for weak acids. They're mostly in the weak acid form. Very little of it dissociates into the conjugate base and H plus. Okay, so that's, now what if that's not a good approximation? What if more of it disassociates? Well, then we need to do some additional calculations, and we'll see how to do those right now.